everyone see my screen?
Yes.
Perfect. All right, everyone, then thank you so much again for joining here today for yet another NIRx webinar. So today we want to talk about the wonderful ePrime extension for NIRx, which is a new product that we have developed in collaboration with our colleagues at Psychology Software Tools, or PST, who are also joining me here today. I'm also joined by our wonderful event and marketing coordinator, Cami, who is working in the background to ensure that everything is working smoothly. First things first, as per usual, let me introduce us to you in case you don't know us yet. We are NIRx. We have been in the business of providing very good fNIRS research equipment to researchers all over the world for over 20 years. It is our ambition to make your research as easy as possible, which is why we put a big emphasis on providing industry-leading support so that you can focus on your research and not on needing to troubleshoot your equipment. And it is our goal to make publishing as easy as possible for you, and very fittingly, today's webinar falls right along those lines because we do believe that the NIRx integration with ePrime will make your experiments even more smooth. With that being said, a couple more notes here. If you want to connect with us and stay up to date on webinars like this or any other announcements, workshops, etc., you can connect with us on social media. We are on pretty much all of the major social media platforms, and a couple of and if you don't want to follow us on social media, you can also subscribe to our newsletter where we update you on our latest product features and releases, user research, and other exciting news once every couple of months, so you're not going to be spammed with emails. A couple of considerations for today. You will be muted throughout the webinar, but you have the opportunity to ask questions anytime. You can just type them in the chat box and we will address them at the end of the webinar. We will also make a recording of this webinar available on our webpage afterwards. And if you have any further questions after the webinar, you can always reach out to us at all consulting or our support email addresses. Perfect. So then let's start right in. I'm going to do some introductions. As I said, I'm joined here today by two wonderful colleagues from Psychology Software Tools, the company who helped us develop our extension for ePrime. So Psychology Software Tools is a small business that was founded in 1987, dedicated to providing innovative and affordable solutions to the neuroscience and related fields. The most well-known products include ePrime stimulus presentation software, the Kronos response device, both of which I've had the pleasure of working with myself as well. Also MR-compatible response and projection systems, MRI simulators, and MRI diffusion phantoms. They have a user base of over 100,000 users in over 75 countries, and you can find them on the web, of course, and contact them at the email addresses linked below. And now, who exactly are we working with today? So I'm joined here by Gretchen, who you can see on the screen, who is the VP of Sales and Marketing at PST. She has been with PST for 18 years, serving in various roles, and at the moment she oversees customer-related portions of the company, including sales, marketing, service, and support. And her background is in biology, psychology, and business. With Gretchen also is Kimberly Barone, who is the product service and support supervisor at PST. She has earned her degree in cognitive psychology and communication and has also been with PST for quite a long time. She, as I said, currently serves as the product, service, and support supervisor, where she oversees the support team. And she values the opportunities this role provides to interact with customers and present customized training sessions to small user groups. And then last but not least, I'm also going to quickly introduce myself to you because I will also have an involved role in this webinar. My name is Franzi. I have been with NIRx for about 1.5 years and am currently a scientific consultant and application specialist for combined EEG and fNIRS here at NIRx. I have a background in clinical psychology and had the chance throughout my career to work with various neuroimaging and psychophysiological measuring tools. And I have spent the last 5 years in North America, but recently moved back to Germany and am now in the NIRx headquarters here in Berlin. Okay, so this was it for the introductions. And just because today's webinar has a couple more components than our usual webinars, I made this little outline slide. So the introductions we already got out of the way. Next, my colleagues from PST are going to take over and are going to present you with a walkthrough of the ePrime extension for NIRx, and they're going to click through the software with you. Afterwards, we're going to show a pre-recorded demo of a real experiment using a pre-programmed script in ePrime, as well as our NIRsport 2 with our Aurora software. And then lastly, as I said, we're going to address any questions you might have. And with this, thank you so much for your attention. And now let's jump in and look at our NIRx extension.
Thank you, Franzi. I'm going to go ahead and share my screen. Okay, so as Franzi said, I'm going to go ahead and do an overview of the ePrime and extensions for NIRx software. In case anyone isn't familiar with ePrime, it is a stimulus presentation software that's been around since about 2001, currently on version 3. It is a very easy to use interface. Everything is drag and droppable into your experiment structure with the option of adding script if you're doing something a little more advanced. You can present stimuli such as text, images, sounds, videos, surveys, all with millisecond accuracy, and collect reaction time data, accuracy data. There's many stimulus selection options such as sequential, random, counterbalancing that are available through our list object that we will take a look at soon. It's very easy to interface with external devices using ePrime. We do that through our task events feature, as well as the extensions that we have for several different partner companies, including NIRx. And something that is pretty special about ePrime is our focus on testing and support. So we regularly are testing Windows updates, even the small ones, before they go public, to make sure that nothing will interrupt any of your studies that you have ongoing using ePrime. And just to show you a lot of our resources, I'm going to quickly pop over to our support site. We always encourage our customers to register their serial numbers and take advantage of all of these resources. It's where you can download the software products, take a look at our knowledge base articles, as well as documentation for ePrime. We have over 100 experiments that you can download and edit if you need to, but already built experiments in our library and in our STEP library, as well as small snippets of inline script samples that you might need during your experiment development. It's also the best way to reach out to our support team. We have a whole dedicated support team that gets back to customers within a couple business days, and they are happy to help with troubleshooting, or even if you wanted to send along your experiment to see if there's anything that you can improve before you start piloting and go through data collection. As I mentioned, the extensions is just one of the ways that we can integrate with external devices. In the EEPRIME extension for NIRx, it really makes the whole process smoother for both the researcher and the participants. There's less bouncing back and forth between computers. You can do all of the work within EEPRIME so that you're not going back and forth from the EEPRIME computer to the Aurora computer. So with the extension, you get a new toolbox of objects in the eStudio interface that you can drag and drop over into your experiment structure. You have the ability to select the Aurora computer, the device and opted configuration for each of the sessions that you're running, perform signal optimization. Again, all of this just through EEPRIME itself, not bouncing over to Aurora. You can start and stop the fNIRS recording, send markers from EEPRIME to your Aurora data stream through various methods, LSL, our Chronos system, or a parallel port. And you can do that at events that are important to you, such as the onset time of the stimulus, or if you're collecting a response from the participant, you can send a marker at that time as well. A really neat feature is the ability to check the status of your NIRx device. So if you're running on battery, you'll be prompted if that battery status is getting low, and then you can go ahead, plug it in, and resume your experiment. There's also some advanced options for setting criteria for signal optimization. So if you don't want the experiment to continue, for instance, unless specific criteria are met, we will walk through that today. So there are a couple of places to start, depending on where you're coming from. So if you already have an EEPRIME experiment and you are looking to add NIRx to your lab, you can quickly follow along our YouTube tutorial on how to install the extension, go ahead and add that package to that experiment, and add the specific package files that will turn your already existing EEPRIME experiment into a NIRx-enabled experiment. So in this video is less than 10 minutes, highly recommended. And from the other group of people, if you're already using NIRx, but you're getting ready to use EEPRIME, we highly recommend starting from a sample experiment. So that's what I'm going to show you today. So there are several experiments that get installed whenever you install the extension. One of which is a checkerboard, which is what we are going to show. So in this sample, we already have everything set up for you. I'm going to show you where the NIRx specific package is located. So this is what comes along with the extension, and also the NIRx specific device, which has these various properties that we'll go into more detail on later, but for now, they're all set to the defaults. So that means whenever you run an experiment session, you will be prompted to select the Aurora computer you're using, the Aurora fNIRS device, and the opted configuration. And it will also run signal optimization in a default way, but we'll get more into that. So in this experiment, we are presenting a welcome screen, followed by an instruction screen. We get into the stimuli that will be presented in using our list object, and then a goodbye screen. And then within there, we've added the NIRx communication. So in this experiment, we are going to open the NIRx device and the communication with that device. We have selected the output device that we're going to use to send our markers in this experiment using LSL. But as I said, you can choose Chronos or parallel port as well. And we're going to perform the signal optimization. The instructions will be presented, and then the NIRx data stream will start recording. And you can see that over on your Aurora computer that's showing the Aurora software. And then we jump into the stimulus presentation portion. So we are going to run 15 blocks, each of which is running 30 trials. And we're just flashing two checkboard images. and sending a marker over to the NIRx data stream for each of them. So these are the two images that will be flashing quickly back and forth. And at the end of each trial, we're going to check the status of the NIRx device. So check its battery and prompt you if there's any concerns there so that you can fix them and proceed. Then we're going to stop the recording of that, say goodbye to the participant, and close out the communication. So just let me show you what that workflow looks like. So when your experiment starts, you will be prompted, and these are the default configurations as is currently set up for. So you'll be prompted to select your host computer. That's the one that your Aurora software is running on, the device that you'll be using, as well as the opt-out configuration. Once those are selected, you'll go into signal optimization, and the results will be shown. You can see each channel as well as this graphical image, and then you can examine those results. You can go ahead and maybe manipulate the optodes to get some better signal optimization and then retry it to see your new results. You can also do that continuously through this button down here. You can start recording in preview mode, and you can accept it and move on, or if you would like to start all over again, you can quickly exit the experiment. And while your experiment is running, you can also monitor your data over on the Aurora computer. So as I said, those are all the defaults, but with the extension, you do have the opportunity to have a little bit more control. So I'm going to hop back over into the Prime interface. So on that NIRx device, let's say that you're running with the same Aurora computer for every session. So you don't want to waste time selecting the computer at runtime. You can save that with the experiment here. Same with the device. So if you only have one NIRx device that you'll be using, same one every time, you can select it and save it with your experiment as well as the optode configuration. And I don't have one with me today, so this is all a simulated mode there. And then for signal optimization, you have some more options here. So for instance, if you may not be the person who is running the experiment, maybe you'll have various research assistants running it for you, and you want to make sure that certain criteria are met for every session before it's run, you can choose those channels that are very important to you and define them as like they need to be excellent only, or they need to be excellent or acceptable for signal quality as well as for dark noise. And then down here, there's a checkbox that says to prevent the experiment from running unless these criteria are met. So, and I'll show you what that will look like during runtime. So if those criteria are met, the research assistant or whoever's running the experiment will see some information about the results, but that it has passed and that they can just continue the experiment when they're ready. However, if it did fail to meet any of those criteria, they have the options that were available in this previous screen to retry the signal optimization after they've done some manipulation with the optodes, or start recording in preview mode just to see if the manipulations they're doing are being effective. And then they can retry signal optimization until they get to that point where they can pass. Oh, and their only other option would be to exit. So that was the basic overview of the Prime and the extension, but I just wanted to give a little bit more information before we turn it over. So all of our extensions are able to be used together. So if you are using NIRx along with like maybe eye tracking or EEG or fMRI, you are able to use all of our extensions in the same experiment. And our Chronos device can I think I mentioned that it can be used to send those markers over to the NIRx data stream, but it's full of many other features. So you can collect your millisecond accurate responses. You can present sound. There's actually a sound card on this Cronus device, so you're not getting any variable latency that you would get with sound cards that are on typical computers. You can test the display timing of your monitor, and as well as record any kind of vocal responses that you might want to collect from your subjects, as long as that vocal reaction time. And on the back of Cronus, you're able to connect an adapter that will allow you to quickly connect to an external device to send markers. So like I mentioned with NIRx, but we have like 30 other ones that you can use for EEG systems, BioPack, etc. So that was my part. I hope I didn't go too quickly or too slow. So Franzi, if you wanted to take it away.
Yes, thank you very much, Gretchen. I think this was a great overview. And now I'm going to share my screen again, and I'm going to show you the pre-recorded demo. Because yeah, you guys at PST, we didn't have a real device, so we wanted to show you guys what the use of the ePrime extension for NIRx looks like with a real device connected. So I'm going to go ahead and share my media player. Can you all see
Yes.
my video screen? Perfect. So then I'm just going to let the video run through. And again, if you have any questions afterwards, happy to take those. I hope you'll be able to hear the sound. Hi everyone, and welcome to this last part of the webinar. So I'm going to show you now what we heard in theory and practice. So the goal of this video is to show you the full integration of the NIRx extension for ePrime in an experimental setup, meaning I'm going to show you how to start up the software, do the signal optimization, and do the data recording. For today, to show you something different than our usual finger tapping paradigm, we have chosen a visual checkerboard experiment that is pre-programmed in ePrime. Accordingly, we have our setup here prepared. I have set up here a 16 by 16 cap with a prefrontal occipital montage on our participant. She is connected to our NIRS board 2 device, 1616 again, which is connected to our recording laptop. The recording laptop for today is also going to be our stimulus presentation laptop, so I'm going to run both ePrime and Aurora on the same computer, but of course you could also run them on separate computers on the same network. You can also see I have a separate screen connected to my laptop, which is where we're going to see Aurora. So ePrime is going to show up on my laptop, Aurora on the screen. So now I'm going to start. So I have installed here on my laptop both the Aurora API and eStudio, both of which I'm going to need today. So I'm going to open up both of them. Here we go. So we can now see our eStudio workspace as well as our Aurora software on the large screen. In eStudio, I'm going to first open up my pre-programmed sample experiment, which again is going to be a checkerboard for today. Now in a second here, I will see in my Experiment Explorer my complete script, including my NIRx commands. I'm going to next start my experiment without further ado. I'm going to run it in windowed mode for today. Perfect. Next, we can see here our screen that always pops up, like our little window where ePrime prompts us to enter our subject information. For today, I'm going to skip through this, as this is not why we're here. Okay, and now you can see the welcome screen, which I'm going to skip. Next, we have to choose our host computer, which in my case is my laptop here. Then we choose the Aurora device, so the NIRS port 2, which is this one, connected via USB, and the device you're using will show up the serial number. So again, you can already see this is the Aurora screen sort of mirrored in ePrime. And I'm going to accept here. And then you can see automatically Aurora jumps to the next step, which is choosing our configuration, which for today's experiment, I have already set up beforehand. So the configuration always needs to be set up in the full version of Aurora. I've already done that for today. Now I'm going to choose my montage, so prefrontal occipital with short distance detectors. And I'm going to accept it. And then automatically you can see now ePrime prompts Aurora to start our signal optimization procedure, which again circles through all the sources and finds the optimal brightness to achieve perfect signal quality in all of the channels. So I'm going to accept these results. And then we see the instructions on the screen. So our participant will see a checkerboard image presented on screen. She has to do nothing but fixate on the middle of the checkerboard. And then as the experiment will run through, we will see the triggers appear on the Aurora screen as the checkerboard flickers. And we're just going to let it run through until the end. Okay, perfect. So this was our experiment. You can see that the ePrime data file was created. So I'm just going to exit from here. And now if I close out of my Aurora screen, if I go to my NIRx data folder, to my checkerboard experiment, I can see my data files that were just recorded, including all of the files, NIRS, SNRF, trigger file, etc. So this was all automatically created. And yeah, that's it for the demo for now. And we look forward to any questions you may have. Thank you. Okay, thank you everyone for your attention. One last thing that I forgot to show in the video was, and I realized, the trigger file. So I'm going to quickly just reshare my screen, and so that you can see the resulting trigger file that I received. So this is exactly the folder that I went into earlier in my checkerboard data. And here you can now see all the triggers that were sent during the experiment. As we saw, as Gretchen showed earlier in ePrime, we have the 254 and 255 for our two different stimuli as they were flickering. Yeah, and obviously this video was cut a little bit, so we didn't see all 15 blocks of the checkerboard. Perfect. Okay, so that's what we wanted to show you, and I see there's already a question. Cecile, I guess you could just ask it. Just unmute yourself.
Thank you. Yes, I was wondering, in case there is behavioral data collected with ePrime, would that be stored in the same folder or would that be stored in a separate ePrime results folder?
Yeah, so the ePrime data files, those will be saved in the same folder as your ePrime experiment file.
So then that means that the user would have two results folder, one for the behavior and one for the fNIRS, right?
Yes,
Okay.
correct.
Perfect. Then do we have any other questions from the audience before we go to our questions that were submitted before the webinar, or our question? Better speaking. Okay, so then maybe I can ask the question that was submitted beforehand. And this one I'll ask to you, Gretchen and Kimberly. How can ePrime bring efficiency for us during data acquisition?
So I'd be happy to take that. There are a couple different ways you can think about efficiency. From the first perspective is simply the process of constructing your experiment. So ePrime is an experiment builder. It's designed specifically to do that. As Gretchen illustrated, it's designed to allow folks, either if they have, regardless of their level of familiarity with straight up programming, folks who have an understanding of basic experiment structure can work with objects that are specific to the language of building experiments. So you have objects that allow you to define the repeatable elements of your procedure. You have objects that allow you to put up a variety of stimuli, collect those responses, and you have objects that allow you to define your stimuli and how you actually do the sampling of that. So there's efficiency in how you can actually construct the components of your experiment. I'm sure that many of the folks on the webinar may be familiar with other experiment builder programs. There are a variety of other commercial and shareware tools that are available, but ePrime certainly excels in the experiment construction process in a variety of areas. One is with the flexibility of designs that you can implement, because again, the objects that are used to drag and drop are customized specifically for experiment creation. So it supports a wide variety of designs. In addition, there's a complete scripting programming language behind ePrime. So as Gretchen highlighted, if you need to do a particular customization that isn't supported simply by the GUI components. For example, you want to randomize your stimuli, but you have a particular constraint. I can't have 3 stimuli from a particular category repeated in a row, for example. That's a common constraint, common example of the type of constraint we might hear. You can use all the GUI elements that Gretchen showed to build your experiment, but just tweak that randomization just a bit by adding a small amount of eBasic scripting into it. So the variety of experiment that can be implemented is extremely large. It is not a canned box set of very small typical designs that you can pick from. It is very, very wide and open-ended. So there's efficiency in how quickly and the range of experiments that you can implement, regardless of your particular specific programming knowledge. Another area of efficiency that a lot of folks may not think about is the accuracy with which you have experimental control. And that accuracy refers to both the stimulus presentation component. So for example, the checkerboard experiment we were looking at, we were flashing those various images at a fairly fast rate back and forth. ePrime has a lot of technology and algorithms built into it that you as the end user don't have to worry about in order to bring about getting that experiment efficiency into your experiment, as well as, so that was on the stimulus presentation side. Similarly, we have great millisecond accurate timing on the collection of those responses. So the checkerboard experiment didn't actually collect any responses on the behavioral side. But as Gretchen had mentioned, you can collect responses and log the reaction time and the accuracy, as well as the response itself that was made. And logging those responses are all done at the millisecond level. So efficiency in terms of not having to worry about all of the customized things that have to be done behind the scenes in order to accurately timestamp all of those responses. The third area of efficiency has to do with primarily the focus here, which was integrating with external equipment. And specifically here, we're obviously talking about our NIRx extension, but the process of dragging those package calls over into your experiment structure, that is bringing over a lot of programming script behind the scenes. So instead of having to worry again about integrating with an SDK, for example, knowing the background details about how I actually communicate with the NIRx system, you're simply dragging over a package and filling in a small number of properties. For example, you know, again, what is my device that I'm working with? What are my optimization values? And you're specifying a small number of properties, and then behind the scenes, we're handling all of that integration. And then finally, as was previewed with the first question that we had, ePrime does indeed log its own data file that contains all of the dependent metrics you're logging. Again, typically the response itself, the reaction time, the accuracy, and any independent variables that the experimenter has chosen to define and to log in the experiment. And that gets logged to its own separate data file, which is very easy to manipulate. Most of our users end up examining our data file with our, we have another package called eDataAid, which is part of the ePrime suite. It allows you to very easily do things like just examine how many trials am I presenting? What was my range of reaction times? What is my average response accuracy? You know, do a simple basic check on the range and the nature of the data that's been collected. And then it's very easy to export that data, either raw trial by trial data or summary data if you want to construct means by condition, extract that to a text file, load that into Excel, put it in the format, whatever data analysis package you're particularly wedded to, more comfortable with using for your extended data analysis. So we offer efficiencies in that wide range. And then to wrap up, finally, I do think it's important to reinforce what Gretchen's already highlighted. And similar to the folks hosting this webinar, we take our obligation and our support to our end user base extremely seriously. So we do have a dedicated team. That's my responsibility, is overseeing that group to help guide you through the experiment development, testing, and confirmation process. So I hope that answered that, the gist of that question.
Yeah, I think that was a very good and very thorough answer. Thank you so much, Kimberly. Do we have any more questions about either ePrime or the ePrime extension? Okay, so I don't think so. So I just want to say a couple of words to close out this webinar. First off, thank you so much, Gretchen and Kimberly, for joining us here today. It's really great having you and having your expertise and you walking us through the extension. And yeah, I want to kind of put everything in the context of, you know, like being actually in a lab and running recordings. Like you might ask yourself, okay, you know, why should I really, like, what's the really big advantage of this extension? So if you imagine you're in a lab and, you know, you're running your rare clinical subject, you know, that's really difficult to recruit, and then someone forgets to press record on your Aurora screen for this session, that is something that doesn't only cost you a lot of nerves, but also a lot of time. And in the end, it just, you know, it makes your life harder than it has to be. And, you know, I think that's exactly where the strength of this extension lies, is that it takes away, you know, all those extra little steps that you might have to consider, and that, you know, if you have someone else running the experiment for you that you have to train them on, it just gives you peace of mind. And I think, yeah, and ensures that your experiments run smoothly, which in the long term, that can save you, as I said, a lot of time and a lot of nerves, and just make your life easier in the lab. So yeah, those were the last words from me. And I guess that's it from our side. Thank you so much for attending this webinar. I believe this is it, and I wish you all a great rest of your day. And if you have any other remaining questions about the extension, anything related to the extension, please reach out to us at the email addresses I showed you at the beginning. And yeah, the recording of this webinar should be uploaded in a couple of days. Thank you so much.
Thank you, everyone.
Thank you.